Hi, I hope this video finds you well. Today we are looking at longest substring with at most k distinct characters. So we're given an initial string called s, and we're also given an integer called k, and the task is to return the length of the longest substring of s that contains at most k distinct characters. So basically, we can reduce this idea to, given a string s, there's some requirement that a substring meets, or that a substring could meet. And of all possible substrings, we essentially want to find out the length of the longest substring that meets that requirement. Now, what is that requirement? That requirement is that it must contain at most k distinct characters. Now, this interpretation of at most k is really just this idea that, let's say we have EC, just the string that we're given here, ECEBA. This would be a string that has at most k distinct characters. Now note that even though E actually repeats, it's still, this substring is still in adherence to the condition of at most k distinct characters, because if we take the number of characters regardless of how many repeat in that substring, you only have an E and C, right? And that is the two characters match that quality. And that two characters are, of course, the value that k is the k that they want. So now, as soon as we expand the string to ECEB, now we have E, we have a C, and we have a B, again, regardless of repeat. And now we have three distinct characters, right? So we're not too concerned about them repeating. Rather, it's just their presence, right? And so we have E, C, and B. So this would violate our condition. So at most k, and of course you could have less than two, right? You could just have one, so it could be, so really at most, the interpretation of at most is really this idea that, you could, the number of, so the number of distinct, right? The number of distinct characters has to be less than or equal to k, right? That's really what at most means, right? So this here is at most, okay? Now, how essentially would you do something of this variety? I mean, how can we go about actually implementing an algorithm that can give us the length of the longest substring of s that has at most k distinct characters? Well, the idea here is that we could look at a brute force strategy, although clearly the brute force strategy won't work. But the brute force strategy is to take this input, this string, and generate all possible substrings, and then perhaps use a utility function that will count how many k's there are in each substring. So it's like a helper method. And then if the helper method has less than or equal to k distinct characters, then it will return true. And if it returns true, then we'll record the length. So that would kind of be more of a brute force way of doing it. So just to sort of demonstrate here, we were given s, and s is ECEBA. And you can actually generate, so this is going to be s dot length. We're going to iterate for s dot length. And so I is essentially going to move one character at a time, right? As you'd normally expect in just a regular traversal. And then for each iteration of I, j is going to span the rest of the string. So j is going to start from wherever I is. It's going to move s dot length I plus plus. And then, just to demonstrate that we actually get each and every substring, I'm going to extract a string here. It's going to be s dot substring. We're going to start from I, and then we're going to go all the way up to j, but you have to compensate, so j plus 1. And we're going to print this out. We're going to print out str. And as you can see here, actually, I think we said I is less than instead of j, and then we incremented I instead of j. So we actually bred something of an error. So as you can see, when we print this out, all possible substrings of this string that we input have in fact been printed, right? And so really the idea here is that, after we get this substring, perhaps we could have like a utility function, like it could be called helper, or it could be called count k, or at most, really, it doesn't have at most k. And so we'll say this is the helper function. It will take in the string, and then it will return back to us whether or not the substring has at most k. So if it has at most k, if at most k is true, or you could just omit doing equals true, you could just say if at most k, then it is a candidate for the maximum length, right? So we'll say max r minus l plus 1, or really just the length of the current string right now. I mean, you don't have to combine those. You could say r minus l plus 1, and then you could bring the length over here. And then, of course, a max would have to exist, and so would this at most function, right? But the problem is, in general, iterating through a string like this, with a nested for loop, it is a quadratic approach, right? This is going to take O of n squared time complexity, right? Because if you look at it, for each character, you're doing an O of n, right? Or for each character, you're iterating through the rest of the string, right? So if whenever you for each character you're going through the rest of the array or string, that's quadratic, right? And then in addition to that, you're doing some logic, which is finding at this helper function is going to do some logic on the string, and in the worst case, it does the logic on the string that contains every character. In other words, it processes every single character, and that's an n of its own, right? A worst case of O of n to do that. So it's kind of a cubic approach, which is largely inefficient. So whenever we want to go from cubic or quadratic, to a linear time complexity, we usually opt for the sliding window, especially when substrings and strings are concerned. And this is actually important why we can't do a brute force approach, because the input size is way too large, right? And so it can negatively scale. So when I encountered this question, I thought, it's like, okay, well, you have E, C, E, and B and A. It's like, okay, well, let me do the standard sliding window approach. I'll have the left and right. So I'll call this, or actually I'll just have letters. I'll say that this is left and this is right. And, okay, well, what I'll do is I'll, like any other sliding window algorithm, I'll keep expanding the window while the condition is met, right? Maybe I'll have a set, right? So I'll have a set here. And in this set, I have E, and then, now I have C in there as well. And then, then I have another E, which is fine. But really, what I'm really concerned with is like, okay, well, if the set dot size, I'll say S, is equal to, or rather is, the structure of the algorithm that I was trying to go for was, okay, like, well, we'll do a while the right pointer is less than the length of the string. That's just standard for any, sliding window algorithm. We will add the character, right? So we'll add the character to the set. Okay. And then, we're going to record the length, right? And that's kind of what we were doing before, right? So we added a new character to the set, and we'll record the length. So we'll say, okay, well, the max is equal to math.max. Either it's going to be what the max was before, or it's going to be the new length, which is r minus l plus 1, right? So add it to the set, record the max, right? And of course, move r plus plus up, just because, we actually have to move this r up, right? So in the first iteration, we added it to the set. We added it to the set, and then, we said, okay, well, max is going to store either what it was before, which is 0, or r minus l plus 1, which is 1. So the max is 1, and then we move r up. And so we're recording the max as we move through. And then the same thing here, the set has now E and C, and then we record the max again, R plus plus. And then, we do this again. This is still fine because even, a set does not store duplicate characters. So even if I do set dot add for this E value, it's still not going to be a problem, right? And so really, we're still good, right? I mean, but then as soon as we come here, we introduce a new character. And now you can clearly see that in this substring here, there are, we had 2 distinct characters before at most, right? E and C, but now we've introduced a B and we've invalidated, what we wanted to. And so really the idea here was like, okay, well, while the set dot size is, the inclination is to say it's not less than or equal to K, right? Because that would, saying this would essentially be equivalent to saying, okay, well, while the condition is not met, right? The condition that we want. So while at most is not met, then, do something. But the issue is you can't do not less than or equal to. So the only possible other case, if it's either less than or equal to, we're fine. The only possible case is like if it's greater than, that's where we would want to shrink. So so while that set size is greater than K, then we are going to, kind of shrink the window, right? So we're going to move L up and so forth and shrink. So we're going to say, set dot remove what's contained at the end, which is what L is supposed to be in charge of, right? So set dot remove what L is referring to, and then of course move L up, L plus plus. And then so this would kind of be the basic structure of the algorithm, right? But the problem is, like, okay, if we remove, if we kind of go through this, right? Okay, so we introduce this new character B, and then we removed E from the set, so there is no E anymore. And then, still the set size is greater than K, right? We want it to be 2, and right now it would be, well, actually, the set size, because we removed that E, it's actually fine, right? And then we actually end up recording the length of this new string. The L is here, but this string is 3, and this is actually not even a valid solution. So this really doesn't even work. So really what I'm trying to illustrate is like, try your solution out and see if it works. So like we come in, we have L, we have R, we come in, we add it to the set. So let's add these to the set, and we'll go through this algorithm once again to show that it doesn't work. We'll add E into the set, we'll add, and then, R will move up, because that's kind of what's happening. We add it to the set, and then of course, we record the, and we're moving R up, right? And so we have E and C, and then, we do that again, right? We add E, E is already added, so we're fine. We record the length of 3, and then, we have R again, move up, of course, and we record, but see, the thing is we're stopping ourselves from recording this string because the set size is now greater than K. The set size is greater than K, we remove from the end, we move L up, and then, and of course we have a B, right? And so we're moving E from the end, and then we end up recording this substring, R minus L plus 1, which gives us a length of 3, and this just doesn't work. And so really the alternative is to use a map. So really what we say is like we have E, C, E, B, A. We have our L here, our R here. Now, instead of a set, think of a map, right? So we have our E, our R would move up, we have a C as well. So we have one C, one E, and then our R would move up again. So we have two. And then as soon as we introduce a B here, we end up recording the B, but the map size, right? So the map size is now, so while R is less than N, we added to the set, we added to the map now, and now it's going to be a map. Okay, but now the map size is greater than K. So then we do a removal process, but instead of removing the entry altogether, we just decrement the size, the frequency by 1. So instead of L, so L will actually, we'll go back into the map and we'll say, okay, we'll reduce that by 1 and move L up. So now we're looking at this substring. Still, the map size is greater than K. So L goes to C. It says, okay, well, now your frequency will be 0 because I'm leaving it. L is moving up, and so if that is ever 0, then you actually remove the entry entirely. And so now you can see that L and R, they're on a new valid substring, right? And so that's how the algorithm is going to work, is we're going to have a map, and the map is going to store the frequency. When we want to do the removal process, when the map.size is greater than K, we do the removal process with a map, right? So that we don't end up annihilating the character altogether. In a set, you're forced to annihilate the character altogether, but we're going to do this in a map. That way, even if there are, like removing E from the set for us would remove the presence of any other E possibly, right? But here we just want to, decrement the count of the particular character, and that will sort of bring us closer to a new possible window. And so that's kind of the idea here. So we're essentially going to work through that. So again, we have and we're going to create a map. So, and I'm actually going to have the map be a character to an integer value. And we can also record the length of the, we can record the length of the string. So we'll say int n is equal to s.length. And then of course we have our map. And while this R value is less than n, so, this is just us moving through the string, we're going to capture the incoming character, right? And that incoming character is going to be what R is referencing, s.char@r. And what we want to do is we want to put, the incoming character, and we want to add 1 to its frequency, but if it's not there, then putting, the way we store the frequencies, we say, okay, well, map.get or default, right? So it's either going to get the incoming character if it exists, the value of the incoming character, or it's going to default to 0, and we'll just add 1. So the first time we see it, we're essentially adding 1 there. So this is us just capturing the incoming character and then putting it into the map. And if it's the first time we're seeing it, we're defaulting its value to 0. Otherwise, we're still defaulting to 0. We're just adding 1 so that, the first time we see it, we at least have 1. So this is us just taking the incoming character. And of course, remember what the idea was. The idea was to, we could use int max equals integer dot min value, so that this is the smallest value in Java. The first value that we come across will obviously be bigger than the smallest value in Java. So for max, you use integer.min value. For min, you use integer.max value. So really the idea is like the max will either be what the max was before, or it will be this new length, r minus l plus 1. It will be this new length. Usually people just revert to not capturing the length in a variable and just saying r minus l plus 1. Either it will be what the max was before, or it will be the length of the current substring. And of course, R has to move up so that we can move through the string 1 by 1. And then in here, where we capture the invalid case. So there aren't any maxes that are recorded that are invalid. So remember what we said, at most means the number of distinct characters must be less than or equal to k. Okay, so we can't say while we can't say while. So what would we actually say here? While the map dot size, we can't say while it's while it's not less than or equal to k, right? We can't really say that. The next best thing to say is, while it's greater than k, because there are only three possibilities: either it's less than or equal to k, or it's greater than k, right? So we're saying while map dot size is greater than k, then we shrink the window. So we're doing the shrinking process, and that shrinking process, instead of removing it entirely, it's going to be, okay, well, map dot, this is how you update a value. We're going to first capture the end variable, right? So the variable at the end, or let's call this the beginning character, right? So the beginning character is going to be what L is referencing, and basically we just say, well, we're gonna put the beginning character. This isn't going to create a new key. It's just going to go to the old one, and we're going to say, just take what was already there and subtract it by 1, right? And then of course we move L up by 1. But the thing is, eventually when we subtract one of these times, the frequency could hit 0. So, basically we would just say, if map.get the beginning character, if that frequency is 0, then we actually want to remove that beginning character, right, from the map. And that way the map size eventually can become greater than less than or equal to k, and then we can actually move on. And then eventually you'll just return, what the max was, right? And so this should ideally work. Yeah, so this part actually goes here. If the map.get the beginning character, yeah, so we essentially want to get the beginning character, and then we want to judge if it's equal to 0, because eventually it will be, right? And so as you can see, like the time complexity in terms of, we're using a sliding window approach, so the time complexity is in order of n. So it's a linear time complexity. We are using a hash map, however, and that the usage of that hash map, in the worst case, we store all possible characters, and there are no, we actually don't ever shrink, and so at the worst case, our map stores n characters, in which case the worst case is also order of n. So we have O of n time and O of n space. You could possibly replace the hash map with a character array, a character frequency array, and do it that way. But this is also a viable solution.